Hello, everyone. Thank you for coming. I would like to thank organizers for giving me this opportunity to show you actually the topic that I like most in the data science. So, I hope that I will show you during today's presentation that data visualization is an art. So, you have an artist thinking about some muse, then it has an insight, and then the masterpiece is created. And so the same is with a data scientist. There's a data scientist thinking about data, having an insight, and then creating a beautiful visualization. So a little bit about me. So I'm currently living in Czech Republic. My background is genetics. My PhD is in populational and forensic genetics. And currently I'm working as a data scientist consultant, and together with my husband, we are doing programming courses for data visualization and data analysis. Okay, so before we'll go more into what Gestalt principles are, there is some to get into the mood, a few answers. So, which pattern do you think is random? So, who thinks that it's left? And who thinks that it's right? Okay, so so the random pattern is the right one. And why it's so? Because normally here are some clusters which are normally created, but our mind tends to perceive these clusters as something non-random, even though this is perfectly random. This is a pattern where there is some repulsion between particles, so this is not random. So by here you can see that our mind is not very good in perceiving randomness. That means that in each visual image that we have, we try to make some structure. And what does it mean for our data? If we are not emphasizing the idea that we want to give to the audience will find the idea themselves, and it could be not the idea that you want to send to them. Another thing, maybe you know about the history. So in US there was a mathematician which during the Second World War was working on how to make airplanes more stronger. But if you put more metal, the plane becomes heavier, and it's not good. So when you are putting more metal, the thicker layer, you need to put it into the right places. So what they did, so they looked at they looked at the airplanes that were returning back to US, and they looked where was the most damage. So the first idea, this is the airplane, and by black you see the most damage. And so the first idea was, we put more metal where the damage area are. Sorry?
Wrong idea.
Right, it was a wrong idea. So this person, he was thinking the opposite way. He said, okay, but we do not have the whole sample. So here we see, okay, these are the blank areas, but we're looking only on the airplanes which are returning back to us. So the airplanes that were not returning back, it was due to the damage in this area. So instead of making more metal here, they put it here. And that makes airplane stronger.
Makes sense also. The pilots are in some of those areas.
Yeah, true. So you see, I'm not a specialist in that. The other effect, also to get into the mood, is the priming effect. So here you see, you need to fill in the letter. So you see all the food, you can fill in that it's soup. So yeah, it depends. So maybe that was not working right now. But the idea of the priming effect is that some information that you put not in your data but near your visualization can lead the audience to make some conclusion. So it's priming, and then you are making not independent conclusion. Okay, so the data visualization has the three main steps. You have a question, so you want to answer on some question. You are exploring the data, and you see the answer. But this is not only schema for the data scientist. The thing is that the same schema must be for the person who look on your data. So you put a question for the person explore the data, and you help person or your client to explore the data in such way that he has an insight, and you hope that the insight is the same as your insight. So here I'm not talking about manipulation of the data. I'm talking about finding the pattern in the data, hopefully non-random pattern, and emphasize this pattern to your client. So client will explore the data and see the same thing that you are seeing. Okay. So if you are into data visualization, you'll definitely know the name 𝗏𝗏𝘀. If you don't know it, I really suggest you to Google that person. He has a lot of interesting books. He really combines art and data visualization a lot. And so his famous quote is, if the numbers are boring, then you've got the wrong numbers. Here, what he's trying, so these are the same plots with brain mass and body mass. And here you're making, he makes the plot to look more interesting, also by adding some non-existent creatures. So the person will explore and see that these are definitely not existing. And the thing here, what I forgot to tell you is, I will show you some principles and I will show you how I'm doing it myself, but it's not like that you must do the same, because it's an art. Everyone has a different taste. So you can look at what I'm doing, take something, and maybe create your own data visualization style. Okay. And before we start, 𝗏𝗏𝘀 also came with the word chart chunk. He created ink to data ratio and say that you don't need a lot of the junk, only numbers. This is a questionable. So here there's obviously a lot of information. Okay, so when you look on this graph, on this plot, you don't know where to look. There is a lot of messy symbols. On the other hand, this graph, even if it's chart junk, look at this graph and this. You saw thousands of this graph. It's one of the, you will not remember it, never. But this will make it more interesting. So it's like a questionable. Okay, well, this is, and maybe one of the very classic example of chart junk is 3D bar plots or 3D pie charts in Excel. This is what could be worse than pie chart is a 3D pie chart. Okay. Also to look at the data for visualization, maybe some of you know Eskom quartet. This is an interesting data set where the same mean value and the same variance, but the distributions are completely different. And if you look at the table, you don't see it. Okay, obviously a lot of numbers, unless you really need to look into that. But if you visualize the data, there is a clear that the 4 data sets are different. And so now we go into Gestalt perception laws. So Gestalt is a German for unified whole. And these are the principles. There are, if you search for the, if you Google for Gestalt principles, you will, there will be a lot of information about logo creation. So I think that after this presentation, you will see the Gestalt principles in each logo that you will see on your way home. So these principles help us to understand the way we see things around, and we can use these principles to make our visualization be more effective. And one of the people who proposed this, who created this principle, said that the whole is other than the sum of parts. So it's not greater, it's just other, and you will see in a minute why. So this is maybe, unfortunately, for those of you who are sitting in the first row, so some of you maybe right now see the face of the lady. So this artist, 𝗙𝗲𝘀𝗁𝗃, he makes the whole his images are created based on these principles. This will be the first principle of simplicity that we will look. Then there is another his image, very nice. Horse made of horses. And this is quite interesting. Again, depending on which distance you're looking at. Yeah. So what is the principle? The principle is simplicity. When you look on this image, depending on the distance, you don't see the individual breath loss. You see the simplest image. For example, here, this is the logo of Unilever. You also do not see each different symbols. You see U. So the first law is that the figures are seen as their simple elements instead of the complicated shapes. So we'll see the easiest shape. If you remember about Olympic circles, you see circles. But if you look closely on the logo, they are not circles. They're interrupted curves. But we are perceiving them as circles. So what does it mean for us when we are making data? That we need to arrange data logically whenever possible and keep, I'll show it to you here. So for example, if you can arrange your data in the easiest way, do that. If you can rearrange your data so there will be the simplest shape, then do that. The next principles is proximity. So elements that are close to each other are perceived as one cluster, one whole. So define what you want to tell by the chart and then create groupings. So how you can create groupings? You can create groupings by making different colors or different shapes. By this, for example, here on this side, you see that we see it as a blob. But once we introduce the color, we see this part is distinguishing from this. Same goes with the similarity. So the objects that are similar to each other, we perceive that they're the same. For example, so that means that we can use same shape, same color, same size to make the objects look the same, and we can use distinctive characteristics to make it look different if we want to emphasize difference. For example, here, I want to emphasize that this point is different from all of the others, so I'm using here color to say that it's different. Another thing is continuity. So here, for example, when you look at the logo, you see as the leaf is flying like that. So you follow the lines. The same as here. you see that there is a spiral lines, but in truth, there is no lines here, and you are following the motion. So how you can use this principle? You can make the lines and group different data together so you can see if the data are similar or not. It's better to show it like here. So if I want to establish relationship, for example, here between sepal width and sepal length, this is a classical iris data set. So I'm using the line, and here I'm using also the confidence interval for the line fitting in order to emphasize the line. So from here, I'm expecting my client to see that these two species are in the same, and this is different. Another is figure and ground. So here, if you look at it, you're perceiving tree and the stem. And back, you see the river. But there's nothing like that. So this is something that we are creating as people in our mind. Okay, so what you need to do is you need to ensure that there is enough of contrast between the points. You can see it here. For me, clearly, this is more contrast than this is. So I will go with this background, or I even sometimes go with, so this with a white background. And one of the principles, before I go to examples, I think the last that I will show, it's closure. So this, when we look at it, it looks like a panda. But again, if you try to focus your vision, this is not a panda. So the closure, principles of closure is that you close it, you feel that there is a body here, and this is the head. It may be even more visible here that we see that there is a giraffe, even though we need to make all of the, we need to things. So because we know that this is a giraffe, we perceive these groupings of different shapes as a giraffe. And how you can use this in your data visualization is that you can make shapes. So by this, you are, even though the for here the data are not exactly in the as the oval shape, you will the client will perceive it, or the person who look at it perceive it as the oval shape. This is not about Gestalt principles, but the thing to think about. So when you're thinking that your visualization will be for a lot of people, maybe think about colorblind friendly palette. In R and in Python, you can create a palette which is for the colorblind. And why I put this strange thing, who knows what is that? Yeah. So for those of you who do not know, so in our eye, in the human eye, we have 3 different types of receptors to perceive color. So if one of the group is missing or have less receptors, this is a color blindness, and that's why we need to adapt our color palette. Mantis shrimp has, I think, 11 16. Or okay, 16 different detectors. So we even cannot think like what colors do mantis shrimp see. So if you're interested into that, I definitely, and it's very colorful. Maybe it could even describe itself if it could talk with what colors does it has. So that.
Actually, its brain can't receive all of the receptors. I mean, it has 16 receptors, but it can't process all of them.
Yeah. Yeah. So, okay. So now let's look at the examples. For the examples, I took World Happiness Report. This is a yearly report for different countries from 2015 to 2019, and it's available on Kaggle. So when I was preparing this presentation, I tried to search for something interesting in the data. You obviously, when you are doing on your project, there is sometimes you need to search interesting in the data. Sometimes you already have your question set. So here I was looking at the economy, GDP per capita, and the happiness score. So I made a plot. So I made a lot of plots. Here I will show you just the 3 that I think that they are like good examples. So I clearly see the relationship here. So let's emphasize it. I want to emphasize it, so this is before plot, and then I will show after plot. Okay. So because I see the relationship here, I can emphasize it by fitting the line, and then, for example, either making the line thickness more, making the points not so important, so there will be not so much of the destruction, so the points will be not in such bright color, and maybe emphasizing the line by making confidence interval of the line fitting. So this is what we got in the end. So not so bright points, bright line with a confidence interval, and some questions. So more money, more happy. The person need to figure out themselves. Another example is from this data, but not with a happiness score. So it's life expectancy. So these are the different regions: Western Europe, North America, Australia, and so on. And here is the box plot with the life expectancy. So when I look at this plot, I can see that there is something like, I saw there are 3 groups. The first one, the second one is like this, and then the third one with a life expectancy. So what I did, I reordered the box plots. So this group is together, and then I colored them into each group into the different color to emphasize that there is roughly 3 different types of countries based on the life expectancy from this data set. So this is what we get. So the first, like the more developed, then the second, and the one was sub-Saharan Africa. And again, I put a question there. So maybe you know there is some like trick on the Instagram. You put a photo and you ask people a question. So by that you are promoting reactions. So this is the same. You ask the question and you are promoting the person who is looking at your graph to answer it themselves. So they explore it. And so the third example is I looked at the happiness score and the generosity. And maybe you see that there is 1 point out here. So I thought, that could be interesting to look at that point. So again, I make the background, I make all of these points gray, and I will use the different color. So this is a proximity and similarity. I will use the different color here. So like not very contrast color here, contrast color here, and then I will actually label what the country it is. So here is the result, Myanmar. And I was surprised, so I Googled that, and Actually, yes. The world's most generous country. So if you want to look at the example that I did, I made it in Matplotlib and Seaborn. So it's on my GitHub, Gestalt, and my GitHub is Anastazie. And you can find the slides for the presentation there. And thank you for your attention. I'm looking for questions. Can you please speak louder a little bit?
Could you give an example of your actual work in day-to-day life that visualization really help you with a story that actually?
Yeah, so what I usually do is I try to put, for example, if I want to show much information to data, I try to split it into different plots. And I'm doing the principle, what I'm using really quite often is this one, reorganize, to make it look simple. So if I see the trend that in a bar plot that is increasing, I will reorganize the data. If it's not the date, this is not, I could not reorganize. So yes, this principle I'm using quite a lot.
When you create a graph with colors, do you think about blind colors, people that like to use another palette?
Yeah. So, yeah, here I actually, so sometimes I'm using palette for the color blindness.
What are each one of these bars?
So this is how. So this is the palette, how people are perceiving it without color blindness, and these are the different types of color blindness.
What type do you know? Just interesting. What each type is.
Oh yeah. So there is abbreviation, and I do not know So the most common one. The most common one, which is affected mostly by men, because it's on Y chromosome, and it's about like 5% or 7% of male population in the world is affected by that.
It's the second from the right. Red, green, color blindness. This is the no. שאלות? אוקיי, תודה, thank you very much, Anastazie.